Okay, let's take a look at some more ways that we can use arrays in Java. We're going to be looking at references, searching, copying, and deleting. So let's start off with copying an array. If you looked at the difference between passing by value versus passing by reference, you'll already know that if we try to pass an array, we will be working on the same array instead of a copy of it. So unlike when we use normal variables such as integers, if I make a new integer and assign another variable to it as its value, this copies the value from integer a. This means that if I change the value in b, or if I change the value in a, they will result in being different values instead of the same. If I want to instead work with arrays, well, let's create an array, populate it with values that are equal to the index numbers, and then make a new array where I'm going to assign my old array as its value. Now, unlike with our integers, this will copy the reference since the value of the array is the reference to its values. Since I am copying the reference, this means that they will have the same reference and they will be referring to the same array. This means that if, for instance, I change the index 0 to 5 in value, if I look at my second array, numarray2, and I print both of them, you'll notice that they have the same values instead of different values. This is an important distinction to make in realizing that we cannot copy arrays the same way that we copy all our other values such as integers or booleans or strings. Instead, if we want to copy an array, what we need to do is copy the values one by one. So I'm going to recreate my new array again of numarray2, and I'm going to say it's a new int array and with the same length as my original array. Then I'm going to create a for loop which will go through all of the elements in my array by starting at index 0 and stopping when I is equal to or greater than numarray2's length. Remember, it does not matter which array I put in here for my condition since they should both be the same length. I am then going to make the index of one array equal to the index of the other. So this means the first time through my loop, when I is equal to 0, it will make the values at index 0 of each loop the same. It will then do that for index 1 on the second time through the loop, index 2 the third time through the loop, etc. and etc. This will copy the values one by one instead of copying the reference of the whole array. Now, if I check if their indexes at 0 are the same, they should be since I haven't edited anything. However, this is because we haven't changed a value yet. If I go and change for index 0 of my original array to 3 now, this should mean that my original array's value at index 0 is 3, while my copied array's value at index 0 is 5. And there you have it. This allows us to create copies of arrays without changing the values in one array affecting the other one. Please make sure that when you're creating a new array that you create a new instance of the array and then copy the values one by one instead of trying to assign the old array to the new array. Now let's take a look at searching, and more specifically the sequential search. What we're going to look at first is getting the last occurrence of a number if it is found inside of the array. So what we're first going to do is decide what number we're going to look for, in this case 2. We are going to create an index value which I'm going to set to -1. The reason I choose -1 is because negatives cannot be indexes within our loop. This means that if we do not find the value inside of our loop, we will instead find -1 as our output statement telling us that it does not exist inside of the array. Last but not least, I'm going to change the value at index 4 to 2, just so that we have two occurrences of the value 2, one at index 2 and one at index 4. We should receive index 4 as our result instead of index 2, since we are going to be looking for the last occurrence of the number. So what we're going to do is create a for loop where we're going to go through every index in the array again. Once again, this will start at 0 and stop at 1 less than the array length. Then what I'm going to do inside my for loop is create an if statement where if the value at that index is equal to num, I'm going to replace index's value with I. Now, keep in mind, this means that index's value will get replaced with 2 when we get to the first occurrence of the 2 in our array. However, that will be replaced by the end of our for loop by the time we get to the end of it, because it will get replaced again at index 4. So let's print out the index to see if we're correct. And there you go. We got index 4 as our result. Now, this is great. However, in most cases, we want to find the first occurrence of a number, not the last one. So what we're going to do for that instead is we have two options. Both of them start the same way by creating a for loop that goes through the array. They also create an if statement, which will check if the value at the index is equal to the number we're searching for. However, this time, when we replace index with I, we're going to add a second line of code after it, where we are going to make I equal to the length of the array. The reason for this is this will make it so that our I value will not... The reason for this is so that our I value will no longer be true in our condition. If our I value is equal to the length, this means our condition is false and our loop will end. This means as soon as we find the first occurrence, our loop will end and we will not replace index again afterwards. If I print out index now, instead of getting 4, I should get 2, the first occurrence. The second option that we have is to use something called a break statement. The only difference between this code and the previous one is the one line here where instead of changing I to the numArray.length, I've used the statement break. The statement break will break out of our loop right away as soon as it gets to the word break. The downside about this is that break is not always suggested, since you can break out of more than one loop if you have nested ifs and loops. It sometimes means that we don't know which loop we will break out of and can cause issues in our code. If you know that there is no code following the statement that you are getting to, then you may want to choose a way of making your condition false instead of using a break statement. Once again, if I try this, I should get the exact result I got before, which is 2. Last but not least, let's take a look at removing an array. In other words, this means getting rid of an array completely and making it so that it no longer refers to any value. In order to do this, I am going to make my numArray2 equal to a value called null. Null removes the reference to its value, meaning that if we want to use an array, we can't anymore because it has not been initialized. Null deletes the variable reference to any data. In other words, it's a way of thinking that it uninitializes the variable. If I print this out, you'll notice that I will get the value null now instead of getting something from our array, or for instance, the location of the array which we have gotten in the past. The upside about this is that we can check if an array has a null value. In other words, it does not have. In other words, it has not been initialized. We can do that by comparing the array to the null value and seeing if they are equal. If they are, we can do something in our code appropriately, like in this case, we can print there is nothing there. That concludes this lesson on arrays, part 2. Thanks for watching and have a great day.